Good morning, my dear students of grade 8. We are continuing through fourth chapter, and for past few lectures we have been combining our class with grade 9 because that part of lesson 4 is same in both grade. Okay, in a sense, that part, that means velocity, acceleration, okay, uniform and non-uniform motion, distance, displacement, speed versus velocity, vector versus scalar, okay, rest and motion. All of these parts are actually the lesson of grade 8 that are revised in grade 9 as well. That's why I took the class as combined form. Today the only topic remaining from that lesson is relative velocity. Okay, today we are going to discuss about relative velocity. Okay, what do you mean by relative? Relative always means that comparative, by comparison. Okay, let's say if you are not moving, okay, you are not moving and another object is moving at a speed of 10 kilometer per hour. Okay, and then you see the object is moving with its actual speed. But if you are also moving at the same speed, okay, suppose you are also moving at the speed of 10 kilometer per hour, then when you see that object, you will see that the object is not changing its position relative to you. Getting it or not? The object is moving at 10 kilometer per hour. Its actual velocity is 10 kilometer per hour. And you are also moving at 10 kilometer per hour velocity. Your actual velocity is 10 kilometer per hour. But in that condition, when both of you are moving with same speed, in that condition, what you see, the object is not moving at all. Okay, you feel that the object is not moving at all. Actually, the object is moving, but you feel that object is not moving. Okay, in that case, to you, the velocity of object appear to be 0 kilometer per hour. See, its actual velocity is not 0, but to you it appears to be 0. Okay. Similarly, if you are moving in this direction at a speed of 10 kilometer per hour and there is another object moving toward you, okay, in opposite direction toward you at a speed of 20 kilometer per hour, then what you see that the object is moving even faster than it seems. Okay, now when until it reaches to you, the speed of object seems to be minus 10 kilometer per hour. 10 kilometer per hour, because it is moving with 20 kilometer, but you are moving at 10 kilometer. Okay, until it reaches to you. Okay, okay, you are moving in this direction with 10 kilometer per hour speed. The object is moving toward you 20 kilometer per hour. Okay, that means in 1 hour time, distance between you and object will be changed by 30 kilometer. In 1 hour, you have, suppose you are at this position, yes, and the object is here. Okay, and the distance between you is 100 kilometer. Suppose the distance between you is 100 kilometer. Now you are moving at a speed of 10 kilometer per hour and this object is moving at a speed of 20 kilometer per hour. But in 1 hour you would have moved, okay, by 10 kilometer, whereas this object would have moved in 1 hour by 20 kilometer. That means the distance between you two will be only 70 kilometers. See, your distance changes by 30 kilometer in 1 hour. So this object appears to be moving at the speed of 30 kilometer per hour. Okay, whereas the actual speed of the object is only 20 kilometer per hour, but it appears to be moving with 30 kilometer per hour. Alright, any confusion here? Okay, similarly, let's take another example. Suppose you are in a bus. Okay, your bus is moving at speed of 40 kilometer per hour. Okay, and there is another bus. Okay, that bus is moving only with 20 kilometer per hour. Okay, now what happens? Your bus is actually overtaking the another bus. Now in such condition, if you are on road, whenever you take some journey through bus, please notice this: when your bus overtakes another vehicle, then keep your eyes focused on another bus. The bus seems to be moving backward. Yes, you might not have noticed it, but the bus seems to be moving backward. That means velocity of bus appears to be minus 20 kilometer per hour. Okay, the bus is not moving backward. The bus is moving forward. Okay, and the bus is not moving at speed of minus 20 kilometer per hour. It is actually moving with plus 20 kilometer per hour. But it appears to us that bus is moving backward. This is also apparent velocity. Okay, so in these three conditions, in these three examples, what we have seen that if the observer is also moving at certain speed, then the actual speed of another moving object does not appear to be so. Okay, so that velocity which appears in reference to another moving object is known as relative velocity. Here actual velocity is 10 km per hour, but relative velocity is 0 km per hour. Here actual velocity is 20 km per hour, but relative velocity is 30 km per hour. And here actual velocity is 20 km per hour, but relative velocity is minus 20 km per hour. Okay, so relative velocity is the apparent velocity. Okay, so you can write the velocity of a moving object in reference to another moving object is known as relative velocity. Okay, now if two objects are moving in same direction, then velocity of AB, that means velocity of object A in relation to B. You are in the car B. Okay, you are in the car B and you are observing velocity of A. In that case, the relative velocity of A would be VA minus VB, because you are moving in same directions. Look at this example, or remember this example. If you are moving in same direction, this is car A, this is car B, and you are here, you are observing velocity of car A, sitting in car B. Okay, then the relative velocity will be 20 minus 40, that means minus 20. Okay, if you are moving in same direction, then relative velocity is obtained by subtracting the velocity of two cars. Got it? Now in this example, you can say velocity of car A is 20 km per hour minus velocity of car B is 40 km per hour, and it gives you minus 20 km per hour. This is the solution. Okay, understood? Okay, now another case, if two objects are moving in opposite direction, then what happens? See the example of this case. The two objects are moving in opposite direction, means their velocity is added up. Yes, so VAB is obtained by VA plus VB. Okay, these two cases, remember, these questions are very common and very easy also. It says if two objects are moving in same direction, then their velocity is subtracted, and if two objects are moving in opposite direction, then their velocity is added. Okay, now let's discuss a numerical regarding. Okay, the question here, two vehicles A and B are moving with the velocity of 15 meter per second toward east and 10 meter per second toward west respectively. If they start from the same place and the same time, calculate the distance between them after 5 minutes. Okay, let's revise the question. This is original position, yes, and both of the vehicles are the same place. Both of them are moving, starting to move from same place. Vehicle A is moving toward east, yes, at a speed of 15 meter per second. It says so. The two vehicles A and B are moving with the velocity of 15 meter per second toward east. That means of A. A is moving toward east with 15 meter per second and 10 meter per second toward west. B is moving 10 at the speed of 10 meter per second toward west. Okay, now you can see the two cars are moving in opposite direction. Okay, now from here you know what to do, how to find the relative velocity. Here are write the given information. Velocity of car A, VA, is equals to 15 meter per second, and velocity of car B, VB, is equals to 10 meter per second. Since they are moving at opposite direction, okay, you know what to do when they are moving in opposite direction. Relative velocity of car A to B, that means VAB is equals to VA plus or minus, it should be plus VB. Okay, or VA is 15 meter per second plus VB is 10 meter per second, means 25 meter per second. So suppose you are in car B, then once both cars starts to move, it appears that car A is moving at speed of 25 meter per second. Actually car A is moving at speed of 15 meter per second. Okay, but due to your own velocity of 10 meter per second in opposite direction, car A appears to be moving at the speed of 25 meter per second. This is relative velocity. Okay, again now you are given time. Yes, time equals to 5 minutes. Convert it into SI unit, that means 5 into 60 second. It gives you 300 seconds. Now if in 1 second the car covers 25 meter, in 300 seconds what should be the distance between these two cars? That means distance S equals to what? And we know distance is calculated by multiplying velocity, relative velocity, into time. Okay, and it's 25 meter per second into 300 second. It gives us 5 3s are 15, carry over 1, 3 2s are 6, 1 7 0 0 meter, 7,500 meter. So by the time 5 minutes, distance between these two cars will be 7,500 meter. Okay, any confusion in this question? Okay, I hope no confusion. Okay, now your lesson is completed here. Okay, this much is your lesson. Okay, so I will be posting the exercise of the lesson in your group, and if you are not in group, then I'm going to show the exercise here also. Okay, so what you need to do is pause the screen. Okay, copy the question or use it as your book. Pause the screen. Number 1, fill in the blanks. Number 2, answer the following questions, then copy the questions. Okay, number 3, differentiate between. Number 4, prove. And number 5, numerical. Okay, pause the screen, pause the video whenever you need, and then copy the question. Okay, and then continued numerical. Okay, this much for today. Submit your work by tomorrow. Thank you, class.